Okay, this is the rest of the lesson from yesterday. I'm also going to briefly go over this overlapping triangle one more time. I did figure out how to do it I was able to successfully redo it using proportions. So I'm just going to go over that pretty quickly. So I'm going to go look at 26.5 on number 120 on page 122. And the triangle has an A, a B, number 4, C, 4, and 6, where these two triangles share the same angle here, and they're both right angles here. So they're similar triangles by being two angles are the same, which is the same as having three angles that are the same, so that they're similar triangles by their angles. Okay, so the first step is that we're going to draw them separately. And the smaller triangle is A, 4, and 6. And that larger triangle is A plus B, C, and 10. Okay, when we add these together. So remember that we're going to find the missing side on that smaller triangle by using the Pythagorean theorem. So that's A squared, because that's the hypotenuse, 4 squared plus 6 squared. So A is going to equal 16 plus 36, which is 52. And when we take the square root of both sides, that's going to give us A is equal to square root of 52. All right. Then we can find the missing side of C just by, we can use proportion or we can use scale factor. So if we use scale factor, we can just say 4 times x equals, we can say 6 times x equals 10 for comparing this one to this one. That is going to give us a scale factor of 5/3. Okay. And if we multiply 5/3 times that smaller triangle side, so 4 times 5/3 is going to give us 20/3. Okay. That is going to be our C. We can also find that using proportions. If we use, so this is scale factor. So we multiply the scale factor times that smaller side of 4 to get that 20/3. If we use proportion, then we would compare. And I could compare the small triangles to the large triangle that it's that same proportional side as to small triangle to larger triangle missing side. Cross multiply and reduce, which would also give me 20/3. Okay, so we have A and we have C. Okay, now we're going to find that last missing side. This is the one that I got tripped up on yesterday. So I'm going to show you how to do it with scale factor and with proportions. So scale factor, we're going to take that missing side and we're going to start out with that A. We're going to compare A to, if we'd say that A times the scale factor of 5/3 is going to be equal to A plus B. Okay, so that means we know what A is. It's square root of 52 times 5/3, and it's equal to square root of 52 plus B. So we multiply, so that's 5 square roots of 52 over 3 equals square root of 52 plus b. Then I'm going to get rid of that denominator so that it makes it easier to solve by multiplying each term by 3. That cancels here. And here, it's just going to, so that'll be 5 square roots of 52 equals 3 square roots of 52 plus 3b. I'm going to move all the like terms to one side. That gives me 2 square roots of 52 equals 3b. Then I'm just going to reduce this radical. So this radical equals 2 square roots of 13. So I'll move that 2 to the outside, square roots of 13. So 4 square roots of 13 divided by 3, and b equals 4 square roots of 13 over 3. Okay, now we can also do this using proportions. So we just set up our proportion. We can say 6 is to 10 as a is to a plus b. And then we're going to fill in what a is. So 6 is to 10 as square root of 52 is to square root of 52 plus b. Then we're going to cross multiply. So that's 6 square roots of 52 plus 6b equals 10 square roots of 52. Then we're going to combine like terms. So I'm going to subtract this so that all the like terms, so 4 square roots of 52. Then I'm going to divide. So this means that if I can reduce that, so 2 goes into 4 2 times, and 2 goes into 6 3 times. And then I'm going to reduce my radical, same as I did over on the other side. That's going to be 2 square roots of 13. So that 2 is going to go on the outside. So b equals 4 square roots of 13 over 3. So you can also use proportion to solve this.